You read from your page, right?
Yeah. It says Mo, Larry, and Curly push on a 845 kilogram boat that floats next to a dock. They all exert a 92.64 Newton force parallel to the dock. What is the boat?
No, I'm just trying to make sure.
If Larry and Curly push in the same direction? B. What's the boat acceleration if Larry and Curly push in the opposite direction from Mo? Page 156.
Alright, so look, you need this thing here, right? Make sure you crack it open so you can follow along. There's some starter notes, 156. As far as that's actually 15. That's a whole lot. 15 points for you. That's a whole lot. Okay, so we're using something on 156 known as Newton's second law for multiple forces. We have Mo, Larry, and Curly. That's multiple people pushing. Right? We got two situations, so pay attention how it's done. Because the equation, when you summarize it, can get crazy. We're also going to be introducing a brand new Greek letter named summation or sigma. Okay? So it's not a big E when you type that in. Right? It looks like a weird 3 or something. It's sigma.
It's like a fancy E.
Yeah, well, it's not E, but it's called a Greek letter, sigma. All right, let me write it out for you. So, because I hate to say it, in mathematics like this high, applied math, you got to use weird Greek letters in engineering. So this is known again as Newton's. Yeah, S-I-G-M-A, sigma.
Yeah.
All right, Newton. So Isaac Newton talked about that guy. The apple fell on his head and he stood on a tree. He said, "Oh, there must be something that makes the Earth fall as well with other planets, right? What could that be?" So this is Newton's second law, and this situation is for multiple forces, right? All right, so let's write it out. Again, the Greek letter sigma is used here, and it means summation. Right? You've probably seen this in math before. So it looks like this. Right? And F, with the little arrow up top, you don't have to type that in, it's hard to do right now. But then you see that little arrow across top, it's a vector. You know it's an actual vector. Is equal to the mass times, mass is not a vector, but it's little m times a, which is your acceleration vector. Forces are measured in newtons. I just said it, nobody listened to me.
You said we got to do it.
Special character? Yeah, but you still got to write that. And that Greek letter is called sigma. I said it.
Sigma.
That's how I know y'all can't be chit-chatting when I'm talking. All right. My mom always say, you can't chew both on the wall. Sigma. It's a phrase. You can't do things. All right. This is kilogram, kg, when you see that, y'all, so you know what number that corresponds to. And don't forget, we've been working on this for a while. Meters per second squared is your acceleration. We talk about gravity and many other types of accelerations. All right, I'm going to box this off to get all these notes. The way I have it, you don't have to just type it like this. You just write what's in that box on page 156. All right, now that we got that out of the way, this is part one of your notes, by the way. You need your known and unknown values, so we can break this problem down. Okay?
The known is part A.
Yeah. By the way, the problem, she took part A, she's right. The problem is found on page 157. If you want to follow along like she's doing. I see she got that page open and ready. All right, what do you, for part A, you write that down, then you can help me out with this points. So part A, what do we have, right?
You have F and then M.
So F for Mo is equal to F for Larry,
and then
F for Curly. So the forces are all equivalent to what?
92.64.
Very good. And you say what goes in that number?
Then 92 N.
Which is newtons. Yep. All right. So 92.64 newtons.
M.
Well, you write it out. And then you say M. That's very true.
Goes 8.45.
845 kilograms.
And this part B.
And that's part A values, right? So now we need what happens in part B, which is a slightly different setup. Remember, one thing changes, which we can't write the same. Okay, so part B, we got, so force of mole is equal to what? 92.64, very true. So let's write that out. But you didn't say newtons again, girl. Okay. Now, by the way, you got 5, 10, 15 so far. This is a newton. So mole is only pushing positive. I think in this situation, the force of Larry and the force, which is equivalent, they push in the same direction against mole. Curly is going to be what? Negative what?
Negative 92.6.
Very good. Okay. No, guys, stop cussing. I know y'all think y'all sitting on the block, but you in my class. Y'all talking like y'all on the street corner. You guys, it's hurting. Y'all talking like y'all on the corner. Oh no, this physics, bro. You tripping.
That M equals 845.
That's the mass, right? And that's again, the volts mass did not change. So we got all of our known ingredients for this problem. All we gotta do now is set up our unknown. Like, what are we looking for in this situation, right?
AX.
Gosh, you said it. AX, because it's acceleration in X-ray. Second squared, that's for part A, right?
Yeah, part B is the same thing.
And part B, you need also the acceleration in the X-axis, but for that different situation. I'm gonna box this off. This is part 2 of your notes. This is part 3, and knock this problem out. So it's part A to part B. Part A. You wanna, hey guys, if I gotta tell y'all stop cussing one more time, we can send you both outside.
Hey, y'all talking over me.
Yeah, y'all are. All I hear is giggles in that pocket. I need y'all to stop. Come on, get serious. Y'all act like y'all want to. Cut it out. All right, so what do we do? We're gonna solve for AX, right? To do so, we have to do some algebra on this equation over here, okay? Okay. This is the force values of X, just made it simple. And we got the mass times your AX, right? So let's take this slowly. Somebody wrote on the board here. I don't know if you get that. So let's take a look. We're first going to solve it in terms of AX, this entire equation. So this simple algebra problem, if you look at it, AX is right here. It's getting multiplied, so we got to divide it. We'll write it again, right? So there's going to be summation. Okay, draw summation. Sigma Fx is equal to the mass multiplied by AX. And all I need to do is get this mass off there by dividing by it. So I'm going to divide by. Okay. I'm going to cross that out. And rewrite the equation. So that becomes AX is equal to that. And then we rewrite it because the summation means it's all these forces being combined. So we kind of zooming into that summation symbol, right? So it becomes AX. Part A is FM plus FL plus FC, right? Over the mass, thank you. So this is this, believe it or not, it's just what's inside of that summation. So sigma means to sum all values. When you do increase summation in math, it's like adding all the elements. Okay. Now I'll plug in numbers for part A. So that becomes AX is equal to, you just plug in this whatever you got. 92. Plus, we got 2 plus another 92. So there's 3 forces. The same value. They're all pushing over, yes, 845 kilograms. So when we calculate that, we just use our fraction button on the calculator or Google. Use one of these for that top numerator. So if I come over here, it simply becomes, let's grab this.
And of course, Mr. Walker.
Right there. You got the answer already? You did the calculation already? So equal sign, parentheses, group the whole numerator. So 92, you could say 92 times 3 up top, but I'm not going to do that. That's just being a lazy physicist. What quick physicist would say? Is that the same this time 3? Wait, hold on. Did he grade you?
Yeah.
Okay, I'm just checking. Okay. And then that's where I group in parentheses on the top, divide by. You do it like this in the order of operations. So 92 versus 4, let's make sure I got it right. On the bottom is 845. Anybody got it for 10 points? No? Yes?
What the answer?
Yeah. Nobody did it?
I did, but I don't know the right.
What do you got?
185.39. No, you got a 0 something.
Yeah, I don't know what you did, girl. Yeah, I don't know what happened over there with you. All right, but 0 point, let's say 329 is acceleration. So we say 0, 329, and that's meters per second squared. Okay. So, and we gotta say which way it's going. The book says, hey, if you add the both, you're seeing that in the diagram, all the forces that are net are going to the right. Okay, because that's molary and curly, pushing that boat that way. The other one you'll see, that's why I designate comma to the right. So yes, you gotta write that. So box that off. And with the last part, this will be part 3 of your notes. This is part 4. Part 4 is basically your part B section. So part B, you can X again. But two of the guys in Three Stooges, they changed direction. So you solve for AX again. However, when you do it this time, we're just going to take this form of it, but we got to change some of these positive and negatives up top. So it becomes AX. And we talk about this situation. Remember, we got 2 guys going opposite. So we're going to have 92.64 in minus 92.64 in minus 92.64 in. So we're going to have a big negative amount because both of those are negative. And it's going to make it go left when we calculate. On the bottom, the weight of the boat has not changed. And I should have wrote the calculation or the equation. You go ahead and do that. Underneath, so you know what I did here, that was F, who was positive? Fm minus F L minus FC over M. So you got all your notes there. And that's really what happened. The final answer is going to be AX is equal to, it's going to be a negative value, but let's just plug it in. Apologize, so do the Japanese thing. So go minus, and go minus here. That gives me a new yield of negative 109. So that's meters per second squared. And it's going to the left this time because it's a negative value. That means the boat's not going to the right, it's more being pushed to the left. It's going to overtake that force of mode. So it's going to be a negative 0.0 109. And that's meters per second squared. This is going to the left. Yes, you have to write that because you're talking about where it's going.
What should these with today?
Hey, little boy.
Which one?
You better have some work done. Don't turn around. You knew I was talking to you.
The one on top? It say AX equals 0.392.
You got 45 for that recorder. Make sure you put the full answers to the right or to the left because it is a designator.